Yeah, okay, so when we're talking about vertical asymptotes, horizontal asymptotes, we should already know how to do those. So the problem is x minus 2 divided by x squared minus 2x minus 3. And Sarah, how do you find, actually Adrian, how do you find the vertical asymptotes? Now this is what I asked you twice last class.
0.
What about 0?
Make it x.
Yeah. Which one do we make it to 0?
X. The 2x, the 2x, or the 3.
The whole denominator. So the whole denominator will equal to 0. So we have x squared minus 2x minus 3 is equal to 0. Do you remember this? Graham?
Yeah, I do.
What would be your next step once you have this?
You start solving it, right?
Yeah, so
Add 3 to both sides.
can we do that?
Yeah.
Alright, let's try that. So we add 3 to both sides. So this is x squared minus 2x is equal to 3. What do you do from here, Graham?
I don't know. That's just a guess. Add 3 to both sides. Like, it's obviously wrong. But
How would we solve this if we were like 1 week ago? What would we do?
I forgot.
Guys, this is just plugging it into the quadratic formula. We could also factor it out. So we ask ourselves, what number multiplies to negative 3 but adds up to negative 2? So what number multiplies to negative 3? We have 1 times negative 3, and we have negative 1 times positive 3. Which one of these adds up to negative 2? Graham.
Negative 1. 1 times negative 3. Or 1 plus negative 3.
Yes. So there's going to be x minus 3 times x plus 1. So we go ahead and what are we doing now? Oh, so we find the zeros of this, which is going to be x is equal to positive 3, because that, when we plug it in there, was going to give us 0. And x is equal to negative 1. So my vertical asymptotes are going to be x is equal to negative 3, sorry, positive 3, and x is equal to negative 1. Now, for my horizontal asymptotes. What is the rule that I'm going to use? Not always. You don't always have to just divide, but we look at the degree, right, Sam? Which degree is higher, numerator or denominator? The degree of which is higher, the numerator or the denominator? The denominator has a higher degree, right? So this is the degree of 1, this is the degree of 2. So because the denominator has the higher degree, what does that mean?
It's 0.
That's when we're looking at for polynomials, right? But when we have a numerator being a lower degree than the denominator, that just means that our horizontal asymptote is going to be at y is equal to 0, like Graham said. Now for my X intercept, this is where we get to the new part, right? We're going to follow special rules. So for the X intercept, our rule is going to be, this is the, let me see, how did I write it? My other class. Yeah. Okay, so for my other class, I told them an X intercept is just where it crosses the X-axis. So this is going to be all the real zeros of the numerator that are not also the zeros of the denominator. What does this mean? All this means is that we're going to take x minus 2 and equal it to 0. And then we solve. So we do plus 2 on both sides. X is equal to 2. And we compare it to the zeros of my denominator. Graham, what are the zeros of my denominator?
They are 3 and negative 1.
3 and negative 1. Do either of these match up to the zero of my numerator?
They do not.
So does this check out?
No.
It does.
Oh, it does?
Right. So we're looking for them to not be equal. So if they were equal, then it wouldn't match up. I mean, then it wouldn't check out, and we would say that there is no X intercept at that point. Now for my Y, intercept, it's going to be the value of my equation when you plug in 0 for X when not undefined. Okay. What this means is this. That you are going to, first and foremost, look at this right here, and you're going to say, okay, I'm going to plug in the value of my equation when I plug in 0 for X. So I take my original equation and I just plug in X's. 0 in my X's. So 0 minus 2 divided by X squared minus 2X minus 3. I'm going to plug in zeros there. So 0 minus 2 divided by 0 squared minus 2 times 0 times negative 3. And this is going to give me, well, 0 minus 2 is negative 2. That's 0 minus 0 minus 3. That gives me negative 3, which is just going to give me 2/3. So we satisfied this first condition. But what does it mean when it's talking about undefined? Well, let me show you another example. If I were to do x plus 2 divided by x, well then in this case I would do 0 plus 2 divided by 0 is equal to 2 over 0. Can I ever divide anything by 0?
No.
So what would this be?
0.
It wouldn't be 0. Right? We can never divide anything by 0, so this is actually going to be undefined. So would this satisfy our condition? But does this number satisfy our condition?
Yes.
Is it undefined?
No.
So does it check out? We're good, right? So, sorry, my y-intercept is going to be equal to 2/3. And if I were to graph this, I would be able to confirm that. Right? I can say x minus 2 divided by x squared minus 2x minus 3. And when I press enter, I see that what's happening? I have a horizontal asymptote at y is equal to 0. Can everybody see this? Horizontal asymptote at y is equal to 0. Two vertical asymptotes at y is equal to positive 3 and negative 1. I have an x intercept at positive 2 and I have a y-intercept at 2/3. Does anybody have any questions to this? This is really all we're doing today.
Not right now, but maybe after we'll do the work.
Yeah, while you're doing the work, please feel free to ask me questions. I'll just be around. Let me know if you have any questions.